4.3. That is the sections on, you know, a first derivative test, second derivative test, check for concavity, the AP type problem, graphing Xerox. Those sorts of problems, section 4.1 through 4.3, that's all the quiz is covering. This is section 4.4, so don't worry about it. Don't think that you have to know it. Here, do I have, Eric, there's someone behind me who wants your attention? Okay, wait. Hey. Someone hasn't awakened yet. So, let me pass this out. 1, 2, 3, 4, 6. Take one pass rest down, please. 1, 2, 3, 6. Boy, those big locking cabinets are quite an eyesore.
Where are you planning on putting them?
Against the back of the room. So I'm gonna have to stare at them every day. That's gonna suck. Those things, I mean, I guess they're attractive as far as office furniture goes, but I don't know what I'm gonna do to them. I get my daughter over and get butcher paper and let her just go crazy.
Just tape it up on there and she'll love drawing on the walls.
Yeah. Yeah, just see if she can do something. I'd much rather look at her art than to look at a neutral gray. Optimization.
No, my greenhouse isn't intended. I live on the college area. Not on it, but it's a mile. That's my greenhouse is built, but I just need it.
Well, the next two sections, we get to do stuff that's applied. That is, you're going to do optimization today, and then you're going to do related rates tomorrow. You know, you may not even do related rates tomorrow. Tomorrow's Friday, right? I have to decide what we're going to do Friday. We might do related rates Friday, or might do something else, but or like a review for the test. But regardless, the next two things we're learning now are optimization and related rates. Optimization is the one where you build the pigsty and you want to have a certain area but minimize the amount of fencing used. Or maybe you're going to wall a garden and you want to minimize the cost of the fencing. Or maybe, I don't know, stuff like that where you're either maximizing or minimizing something. You know, you've got a square and you're going to cut out the corners and make a box, and you want to maximize the volume of that box. That's optimization. And then the next thing we're going to learn after that is related rates. That's the one like the ladder. I don't know if you remember from Mrs. Lofgren's class where the bottom of the ladder is sliding out at a certain rate. What's the top of the ladder sliding down at? Or you're dumping a certain flow rate, a volume flow rate into a tank of water, and what's the rate at which the height of the water is increasing. That's related rates. And so all of those are applications of the first derivative. And so here we go. Optimization. Please read the first four rules of optimization. Please read them now. Okay. Hopefully everyone's read those 4 rules. The most important thing is to express the quantity to be maximized or minimized as a function of one variable. That means you have to really know what the quantity to be maximized or minimized is. For example, if I'm asking you what is the maximum area you can enclose, and then I say a bunch of stuff, your formula better be area equals something, you know? Always, you have to really know what you're minimizing or maximizing. You know, I always feel very sad for those students where I'll say, please maximize the area, and then they'll give me an equation for perimeter and work with that equation. And it's like, hey, it's not perimeter you're maximizing, it's area. So get me an equation for area. Secondly, it's always going to have to be a function of, well, it's not always a function of one variable, but it's almost, in high school, it's a function of one variable. So you're going to find that if you've got 2 variables, you're going to have to do some sort of substitution. Then 2, 3, and 4, you just do the same old, same old. Take the derivative, get the critical numbers, use first or second derivative test to see if they're minimums and maximums, and then express your answer and make sure your answer makes sense. So hey, let's do example number 1. The sum of 2 non-negative numbers is 50. What must those numbers be if their product is a minimum or a maximum? Well, first things first, what is it that they want me to minimize or maximize?
2 numbers.
What about the 2 numbers? Say again, Daniel? Yeah, the product of the 2 numbers. So you really have to have that foremost in your mind, almost to the point that, you know, my equation is going to have to be product equals. Okay, now the 2 numbers. What would you like to call those 2 numbers?
A and B.
A and B, X and Y. Okay, I'm going to go A and B just because Andrew got in there a little bit early. So yeah, A and B. And this is what you learned in first year algebra, is always to define your variables. Let A be the first number, let B be the second number. Okay, so define your variables. Now the problem is I've got a function in terms of 2 variables. I'm gonna have to make a substitution, which means usually you're trying to find a relationship between those 2 numbers so you can substitute in. Well, what's the relationship between those 2 numbers? A and B. What can you tell me about A and B relative to each other?
Oh, A plus B equals 50.
Yeah, they add to 50, right? So you get to say, well, A plus B equals 50, which means A is equal to 50 minus B. Those of you, yes, Daniel?
Isn't the product of A and B equal to A multiplied by B, not A plus B?
Yeah, I was just about to say that. Look at your equation at the top of the board.
Product equals A plus B. There we go.
Thank you, Daniel. Okay, great. Well, I did that on purpose just to demonstrate how important it is. Okay, great. So you guys, and those of you who had Mrs. Lofgren, you may recognize, I think they called one of these guys the constraint equation and the other one the something equation. Do you guys remember those terms? Do you remember what they actually were? What was this guy called? What's that? Yeah, or anyone remember?
It was the constraint. I don't remember what the other one was.
Okay, I think this is the constraint equation, and this is the real equation, the for sure equation, the one we care about equation. Well, whatever. If you didn't have Mrs. Lofgren, don't worry about it, because I'm not going to have you memorize terms like constraint equation and the other term which I don't memorize. But remember, just go ahead and plug in. Now I'm going to substitute. A is equal to 50 minus B, so this product is equal to 50 minus B times B. That is the product, is equal to 50B minus B squared. And now I'm going to do step 2. Take the derivative to find the critical numbers. So I got product squared. Do you mind if I just call it P for product?
That's fine.
Product prime, the first derivative, is going to be 50 minus 2B, which is 2 times 25 minus B. So I got a critical number at B equals 25. Yay. Now, I need to determine whether that's a relative min or a relative max. I'm going to have to use first or second derivative test. Which would you prefer to do, first derivative test or second derivative test? What do you say, Daniel?
First derivative.
Okay, Daniel says first derivative test, and I'm fine with that. But what is it about this derivative here that lets you know that probably second derivative test is the way to go?
It's very easy.
It's very, very, very easy, right? I mean, here, let's do second derivative test. We'll have a chance to do first derivative test next, but let's do second derivative test. P double prime equals, whoops, of course, if you can do it. Oh, what's my problem? P double prime equals -2, which means I'm concave up over the entire domain. And concave up, what does that make this guy? A relative min or a relative max? Concave down. So I'm a relative max, right? Okay, so P double prime of 25 is equal to -2, because P double prime of everything is equal to -2. So because I'm concave down, I'm gonna have a relative max at B equals 25, A equals 25, okay? And what would those numbers, okay, great, so the numbers are 25 and 25, and that gets me a max. Well, that's it for my critical numbers, but they're asking for a minimum as well. What am I gonna have? Wait. Oh, shoot. The sum of two I guess that's okay. I was thinking of something else. So the sum of two non-negative numbers is 50, and I found the max, and they're asking for the min. How am I gonna get the min? What do I have to look, where do I look now for the min? I'm clean out of critical numbers. What's that?
Endpoints of the domain.
Thank you very much, Zach. Wow, good for you, and that was caught on video too. Yeah, the endpoints of the domain. Because these are non-negative numbers, that is, they're either positive or zero, I have an actual, endpoints to this. I have a domain, right? The smallest a can be is 0, and the biggest b can be is 50. Or the smallest b can be is 0, and the biggest a can be is 50. So I actually have endpoints here. And if I'm looking for relative minimums and maximums, or specifically absolute minimums and maximums, there's only two places to look: the relative mins and maxes and the endpoints. So now I'm going to check the endpoints. And of course, at the endpoints, my product is going to be AB, which means my product is 0 times 50, or my product, which is AB, is going to be 50 times 0. But regardless, my minimum is going to be 0. So the maximum that the product can be ends up being 625, but the minimum ends up being 0. So I want you to be aware, on these optimization problems, I'm going to give you at least one optimization problem on not this coming quiz, but the next test, where you're going to have to check endpoints. You're going to have to discern, okay, what are the endpoints of this situation? And then you got to try them. So part B, to get the minimum possible area, it's either going to be A equals, well, the two numbers are 0 and 50. They don't make a distinction between who's first and who's second. So the two numbers are 0 and 50. Any questions about this process? You got to know what you're minimizing and maximizing. You got to get that in terms of one variable. Then take the first derivative, get the critical number, do one of your tests, determine min or max. If they need a min or a max and you're fresh out of critical numbers, you're going to have to try the endpoints. Hey guys, please do example number 2 right now. How many people in this class, by a show of hands, how many people in this class drew a picture? Good, it ought to be every single one of you. You must draw a picture. Any of these type of rectangle problems, you really have to draw a picture. Thanks, Leila. Is anyone having any trouble how to proceed after drawing a picture? What variables did you use? You're doing that the other one. What variables did you use? W and L, okay, that's what I use. Luke, are you here? Parth, are you here? Yeah. Is anyone else absent? Has everybody recognized that it's the perimeter that you're minimizing or maximizing? So you should have something that looks like that, because that's what you care about is the perimeter. What's the area of this crazy thing again?
118,000.
180K? So did you guys figure, well, I gotta get rid of one of these variables, and so did you do length times width equals 180K? So length, what'd you solve for? Length or width? Fatima, what did you solve for? Length, okay. Because it doesn't matter at all in the least. 2 times W plus 180,000 over W. My perimeter. Did you guys get that far? Then the rest is calculus. If you got that far, you were there. You're going to get the right answer, hopefully. I'm going to do the rest. Did I make it a perfect square? What did W end up being? 300? Wow, what a good teacher I am. How many people got that far as finding the critical number is 300? Not many of you, 2 of you. Okay. So I guess the calculus still takes a long time for you. But what I'm teaching you is your ability to get here. You know, once you get there, you're on your own calculus-wise. I'm going to do first derivative test. Why didn't I go to negative infinity? Why not have my domain be negative infinity to 300? Yeah, we don't have negative lengths of sides. The smallest the side can be is 0. Really, it can't be 0, or you don't have a rectangle. So I'm going to plug into the first derivative. This is the intervals of x. This is the sine of f prime. So I'm going to plug in like 1. And I get a huge negative. And I plug in a million, billion, trillion, and I get positive 2. Okay. So, relative min at W equals 300 meters. Length equals 180,000 over 300, which is 600. What do they want? Must the dimensions be? So these are the dimensions. Okay, well, hey, I'm just zipping along all fast and all, but are there any questions or issues on example number 2? Get your equation, take a derivative, get the critical number, do a test to determine whether it's a relative min or a relative max, and then write down the answer they want. They wanted the dimensions, so I wrote down the dimensions, the width of 300, length of 600. One last thing, does that make sense? Yes?
Why can't we just divide?
Okay. Always make sure it makes sense. Does a 300 by 600 fence make sense? Sure. I mean, if I got an answer like negative 200 by a billion or something, then I'd go, oh, something went horribly wrong, you know? But 300 by 600 makes sense. I could have a fence that is like that. 300 times 600 certainly does get me 180,000. So, you know, always double check your answer. Make sure it makes some sort of sense. All right, hey, give number 3 a try. I don't want you to spend too much time being stuck if you did not have Mrs. Lofgren last year. So someone who had Mrs. Lofgren, what's the key to this problem? What do I do now? Yes, Abigail.
You subtract x, which is the represented space.
Thank you. The key, you gotta label these squares x by x. Okay, that's the key to doing this problem. You gotta give those squares, a variable name, and they are x. So now, I hope you see that when I fold these guys up, and by the way, every year I get several students who don't get what's going on. Here's what they're doing. You see this sheet of paper? And then they're going, so now it looks like that. And then they're going fold, 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 fold. And now, ooh, I have a box. So you guys okay with that? That's what they want me to do. So now you're maximizing the volume of the box, assuming that the volume ends at the top of the box and you're not piling things that were, that'll stack in such a way that they could go above the top of the box, I guess. So this distance, this is now 20 minus 2x. This distance here is 25 minus 2x. And the height of the box is x. So you guys getting what it is? So get the volume, take the first derivative, I'll give you another 2 minutes. By the way, how many people are doing product rule here? Okay, if that's what you want to do. I mean, me personally, I would just FOIL it all out and make it into a polynomial. I would just do this, multiply, so you got, what, 500 minus 40 plus 45, so I got 85x plus 4x squared times x. V equals 500x squared, 85x squared plus 4x to the third. And then I'll just take the derivative of that, and I just think that'll make your life a lot easier. Don't do product rule. Of course, you have to get that right. That's 95, right? 50 plus, 50 plus, yeah, 90. Wow, what's my problem? But anyway, presupposing that you can do arithmetic, it should work out just fine. So Abigail, yeah, do it like me, but don't do it like me. Am I correct? Did anyone get 11.3 and 3.68 when they did quadratic formula? Did anyone get those? You did, Chris? Okay, then we must be right. I mean, we're not going to randomly get the same number.
Wait, why did you keep, oh, it's 500x.
Yeah, it was 500x minus 90x squared, etc. Because I had to multiply that x through. And then I took the derivative, and then I did quadratic formula. Well, I'm just going to keep zipping along. Which of these two answers makes no sense?
11.4.
Why? Why can't I do 11.3 inches? Who's going to stop me?
Because you can't take 22.6 inches from 20x.
Yeah, thank you. You can't take 22.6 inches from 20, right? Here's my square. I'm going to do 20. I'm going to do what? 11.3. Okay, here comes 11.3. And now I'll do 11.3 here and 11.3 there. So this one I can ignore. This is the only one that makes sense. Now let's go ahead and see if it's a relative min or a relative max. What would you recommend, first derivative test or second derivative test? I'll tell you, when you got a situation where taking the second derivative is trivial, I would say do second derivative test. V double prime is a negative 180 plus 24x, and now I just got to find what V double prime of 3.68 is. And I don't even know what, I don't even care what V double prime of 3.68 is. I just care whether it's positive or negative. So when I put in a 3 here, I'm going to get something like 80 or 90. Well, that's way less than negative 180, so I know it's going to be negative. And so concave down means it's a relative max. At x equals 3.68 inches. And then there's one last thing. Is that answering their question? What do they want?
The maximum volume.
Oh, they want the maximum volume. So you're going to have to plug that back into the original equation, okay? And so you need to find what V of 3.68 is. And again, you know, for me personally, when I have to plug numbers like that, I'll go 3.68, and then I put store, and then I put x. 3.68 store x, then I just type up, you know, one of these versions of the volume. I don't punch 3.68 multiple times. In fact, I've already got 3.68 right here in my calculator, so I'm just gonna do store x. Okay, cool. And now I'm just gonna type in this guy here, 500x minus 180, whoops, minus 90x squared plus 4x to the third, and I get 820.5 cubic inches. Okay, well, I'm going to show you the equations of example 4, then I'm going to show you how to do example 5, and then we'll be done. And then you'll be on your own. You've got only about 5 of these problems to do, you know, but I think I'll have prepared you. If you need any help, come in after school. I'll be here till about 3:50 or so. Then I have to leave and go to Mr. Jaramillo's 60th birthday party at Logan's Roadhouse.
Wait, he's 60.
Are all the teachers going?
60. Mr. Jaramillo is 60.
He doesn't look 60.
Yeah, he doesn't. That's-
Mr. Shana?
he lives young,
That
yes.
is like maybe it is.
Do all the teachers get invited to that?
Yeah, every single teacher's been invited. We all got emails. So it's like a big, you know, teacher thing.
It's almost like 400.
Yeah, well, I mean, I'm sure there's like 150 teachers on staff, but not all 150 are going to show up. But see, the problem is, you know, Mr. Jaramillo is my boss.
Yeah.
And if my boss is going to have a birthday celebration, I need to be there, right? Or he'll infer that I don't value him as a boss, and that might hurt me in the future.
Yeah.
Remember that, kids. Learn from that.
Which is why, that's exactly why you're paid $113,000.
That's exactly why what?
That's why you're paid $113,000.
Thank you. Exactly. That's why I'm worth every penny of it too.
Mr. Shane?
Yes. I'm sorry. What's that?
What time is the party?
4 o'clock, Logan's Roadhouse. Come by and you'll see lots of teachers and Mr. Jaramillo. And yeah, you know, at these parties, you know what happens, man? Those teachers, they get so drunk. No, actually we don't. It's like teachers are the most teetotaling group of people you could ever meet. Yeah, we don't get drunk. We don't have fun. We don't drink. Okay, here, let me show you example number 4. A cylindrical can has a volume of 1,000 cubic centimeters. Make it with the least amount of aluminum. Well, the least amount of aluminum. Here's my can, right? And I gotta figure out how much aluminum I'm gonna use to make this can. Well, you've got the radius of the can, and you've got the height of the can, okay? And so I've got 2 circles plus the label. And so that amount of aluminum, which by the way we call surface area, the surface area of the can is going to be the area of 2 of those circles, 2 pi r squared. That's the 2 circles, plus the area of the label. And if I were to cut the label and lay it out like that, do you see that this length of the label, well, this here is going to be the height. Someone tell me, what's that length of the label going to be? Yeah, 2 pi r, the circumference of the caps. This will be 2 pi r. So you got 2 pi r squared plus 2 pi r h. That's your surface area. That's what you're going to have to be minimizing. Well, you're going to have to solve for either r or h in terms of each other. And the way you're going to do that is by using the volume equation. Does anyone remember what the volume of the cylinder is?
2 pi r squared times h.
Not 2 pi r squared times h.
Pi r squared.
Yeah, pi r squared h, just the area of the base times the height. Area of the base times the height. So I got pi r squared h. And they tell me the volume is 1,000. Okay, so you're going to have to solve for one of those variables. Which one do you suppose I would recommend solving for?
H.
Absolutely h. Yeah, so you got h equals 1,000 over pi r squared, and then you stick that in for h right there. This. Stick that in for h, and then do calculus. Then take the first derivative, find the critical number, and see if it's a min or max. Now it's going to be algebraically demanding, but it's just algebra. It's nothing I need to teach you how to do. It's something you can struggle your way through. So that's how you do number 4. Get an expression for surface area, substitute for h, and then do the calculus on it. Let's take a look at 5. I'm going to show you how to do 5, and then we'll call it quits. Just a second. For the graph y equals negative x squared plus 4, so it's a parabola that's going like this. Inscribe a rectangle between the graph and the x-axis that has the maximum area. You're going to have to draw your rectangle, and this is what they're envisioning. They want you to put a rectangle in there. And they want that area to be the maximum possible area. Key, get the y-coordinate of the vertex of the rectangle in terms of x. Here's what they want. If this is my inscribed rectangle, I'm going to call this x, and thus that's negative x, so that length is 2x, right? I got to declare that to be x, and now I've got to get an expression for this. The x coordinate is x, because there it is. The y coordinate is going to be the same as the y coordinate of this graph. Y equals negative x squared plus 4. And so if I stick an x in there, I get negative x squared plus 4. You see that? And that's the key. Whenever you do one of these inscribed rectangle problems, always get an expression for the vertex right there, and you'll be fine. You know, and express the coordinates of that vertex. So now, are you okay that I've got a rectangle whose width, or whose length is 2x, and whose height is negative x squared plus 4, right? And so the area that I'm going to have to maximize, because they want me to maximize the area, right? The area is going to be 2x times negative x squared plus 4. And then the rest is just etc. Take the first derivative, find the critical numbers, see if they're mins or maxes, choose the max, and you'll have your x. Is that okay with you guys? But the key, again, is this right here. Getting the x and y coordinates of that vertex there. Then it gives you, it gives you the height of the rectangle, and you got the width already, and that's all. All right. Hey, good luck, you guys. Good luck.